So carbon-aware compute. This is looking at the carbon usage of the compute resources we're using and trying to make sure that everything is efficient as possible. Now this can be achieved in a multitude of different ways, but I want to provide a quick example of how we can make use of the global compute infrastructure provided by organizations like Microsoft, Google and Amazon to simply and automatically move your compute resources around the globe, making sure that you're always taking advantage of the most carbon efficient power grids. Now this isn't going to be suitable for all types of compute, and it's of course not a perfect solution. I don't think anything ever is. But if you understand the options available to you, it may lead you to build your applications and your services in a certain way to take advantage of these tools when it makes sense to you and to those applications. This is particularly key for things like AI services, which can be incredibly compute resource heavy. Now, if we're taking advantage of AI services, maybe we're building a modern microservice-based solution, or even a modular monolith application, we have the option to take aspects of those, maybe compute intensive or long-running services, and move them to resources that, although they may have an increase in latency, are still suitable to the task and can be spun up and spun down in a more carbon-aware manner. Now, of course, it's important to note first, though, that many data center providers are already taking steps to make their offerings as carbon efficient as possible. Microsoft, for example, are looking to be carbon negative by 2030. And Google, well, they're aiming to run on carbon-free energy everywhere at all time by 2030. And Amazon with AWS, well, they want to be running entirely on renewables by 2025 and are looking to be net zero on carbon emissions by 2040. But what about other providers? And what can we do today while we're waiting for all this to happen? Well, let's go and take a look. So as you can see, I've created 3 separate functions in Azure. Now these are all running the exact same code, and this is a simple REST API that reports the location it's running in and a simple breakdown of the energy grid in that location. It's all pretty simple stuff, but this is just an example, and in the real world these may be far more complex processes. Now these are configured as consumption-based functions, meaning that when they're not being used, they power down, and they only spin up again when they receive new requests. This in itself makes them more efficient from a compute resource point of view, as they aren't simply running 24/7, even if they're not being used, and if they're not doing anything. But it does add to the latency, as there is a time penalty on a request when the service has to spin up again. So again, like everything, and like we mentioned earlier, nothing is an absolutely perfect solution. But what we want to do is to look at the options available to us on a case-by-case basis and decide where a setup like this may be applicable. Now you'll notice that each of these is based in a different region. So Australia, the UK, and the East US. Now these are just 3 of the locations available within Azure. There's data centers all over the globe, but I've picked these ones just as an example in this instance. Now on top of these, we're making use of Azure API Management, and this provides us with a single URL to access all of these APIs or all of these functions, and we determine which one we're going to use based on a simple inbound policy. So this activates on every request, and it looks at a simple named value called carbon aware that we have stored in the API management system, and it, based on what value that is set to, it will call the function appropriate in the region that's appropriate. So, for example, if our named value is set to UK South, we'll always call the service running in the UK. And likewise, if it's Australia East, we'll call the service running in the Australian data center. What we'll then have is a service running behind the scenes that looks for the region with the most carbon efficient power grid, and then automatically update this named value in API management so that the calls are always getting directed appropriately. But how are we going to accomplish that? Well, luckily for us, there is a huge amount of information available online. And here we're going to use electricitymaps.com, which also provides an API that we can use from the background. So, for example, in the UK right now, the carbon intensity is 132 grams. And now this is grams of carbon dioxide equivalent per kilowatt hour of electricity generated. And in basic terms, the lower the number, the better, because that means that less carbon is being generated. Now, if we drill down into the UK, we can see that most of the power today is coming from wind sources, so renewable wind. And that doesn't really surprise me because if I look out the window right now, it's pretty windy out here. Now, if we head across to the US, so the East US region where our other data center is running, we can see that the carbon intensity is much greater. And here we have a breakdown of both nuclear and gas being used. So we can use this information to constantly monitor the power grids and move our compute resource around the globe as appropriate. As mentioned before, and I can't stress this enough, this isn't going to be perfect. And there's a lot of nuance involved. But this is just an example of how you might begin to look at these aspects. So let's put it all together. I've put together a very simple site. And this basically has, if we zoom out, a map of the world with some markers and some coloured in regions showing where our servers are located. So we've got our East US server, our UK server, and our Australian East server. And at the moment, the green dot specifies that we're using the East US server, which I think is based in Virginia in the US. And at the moment, that's running at 346 grams of carbon intensity. And we can check this out. If we use our check service button, it's going to go away and call the service. And yet, sure enough, it comes back with this running in East US at the moment. And here we can see our breakdown, which matches up with what we saw previously, where we've got most of our power grid generation through nuclear and through gas. But if we now look at the carbon intensity levels, we had East US as running as 346, but we've got UK South as 115, and then we've got Australia East as 672. So although we don't want to run in Australia, actually running our service within the UK is probably a better bet. So let's turn on our check location and our update location process. Now, what this is going to do is it's going to run in the background, and while it refreshes, it's going to look at where we're currently running, and it's going to determine if there's another region that is more carbon efficient that it could be running in. If it finds one, it's going to update the location in our API management, and that will change the location of where our servers are running. So as you see, it first found our current location was East US, and then it updated our location to UK South. And again, it's now continually checking, and it's saying there's no location change because it hasn't found one that's better for us. And sure enough, we can see our green dot has moved now to UK South from East US. If we check our service again, it was previously registering as East US, and now it registers as UK South. And we can see our breakdown matches this, with most of the generation in the UK coming from wind. So we've accomplished this all in the background with no downtime to our users, and in fact, no one should have noticed the change. And this is where we're saying, pick this for the services that are running, long-running services that don't require immediate response. You can make the changes without your users even being aware that this has happened. And that's it. A simple example of how you can make your compute more carbon aware and look at bringing down the carbon footprint of your organization. Now, if you found this interesting, let me know and I'll look at providing a follow-up that delves deeper into how you can actually calculate the carbon usage of the processes you're running, because we all need to remember that just because we don't own the data centers or the server anymore, someone else does, that doesn't mean our usage of those external systems doesn't impact our own carbon footprint. Thanks for watching.